Hello again, this is part 2 for finding equivalent fractions. Another strategy you can use besides fraction strips and fraction circles is to use a fraction number line. If you have fraction number lines that are already labeled, like this one here, it already has halves, thirds, fourths, all the way up to twelfths, then you can simply find marks that match up to the same in the same spot. 1/2, for example, is pretty easy to find if you just follow the line straight down. There you have 2/4 is an equivalent size jump. It takes 2 of the fourths to equal it. 3/6, 4/8, 5/10, and 6/12. If you want to find one that's a little bit trickier, say 1/3 here, again, I would kind of go straight down. Oh, hey, 1/6, or 2/6 rather. There's 1/6, 2/6. That ends up being the same amount. Again, oh, here's another one. 1/9, 2/9, 3/9, and they all kind of line up. 10ths, ooh, that's close, but not quite. But then here we have 1/4, 2/4, 3/4, and 4/4. So you can compare the size of, not the size of the jump rather, but where the jumps end up, and that is another way to find equivalent fractions. The next thing that we're going to do that you had to do in your book was to use a multiplication chart to find them. And with the multiplication chart, you're using the numbers on the side to create your fraction. And then we're going to find the shortcut to help us figure out which ones on here are equivalent. So let's say that our fraction is 3/4. So I'm going to use the 3 and the 4 from the chart. And honestly, I could turn this dividing line into a fraction bar, and all of these would be equivalent fractions. And honestly, the way that that works is that you're taking the 3 and you're multiplying it by a 2. And you're taking the 4 and also multiplying it by a 2. 3 times 2 is 6, 4 times 2 is 8. And so that means that 6/8 is equal to 3/4. If I hop down here to the 18 24ths, you're taking the numerator 3, multiplying it times 6. And you're also taking the denominator 4, multiplying it times 6, and that will give you another equivalent fraction. Even if you skip and do, let's say we do 6 for the numerator and 10ths for the denominator, you kind of have to ignore this strip here. But this top row would be the numerator, and this bottom row would be the denominator, no line actually. So this would be 6/10, 12/20 would be equivalent because 6 times 2 is 12, 10 times 2 is 20. You could do 18/30, 24/40, and so on. The chart includes a bunch of patterns, and once you get the pattern for finding equivalent fractions, it's another tool that will help you. So then if we look at Math Book page 244, I printed a copy here. It is the second page showing you how to use a multiplication table to find equivalent fractions. So again, they chose the 4 and 8, and if these are fraction bars all the way across, you're taking the numerator and multiplying it across any of the digits in this top row and doing the same thing with the denominator. So anytime you multiply, as long as it's the same number here. So 4 times 2 equals 8, and 8 times 2 equals 16. So that means that 4/8 and 8/16 are equivalent. So really you can pick any number. So I'm going to do 9 for this one. 4 times 9 and 8 times 9. You must multiply the numerator and denominator by the same number though, otherwise they will not be equivalent. So 4 times 9 we know is 36, and 8 times 9 we know is 72. So 36/72 is equivalent to 4/8. Now, with larger fractions, such as 20/40ths, you can also divide by the same number again, and you will find another equivalent fraction. So if I divide both of these by 5, and the tricky part is making sure that both numbers can be divided by that same number, you will find equivalent fractions. So 20 divided by 5 is 4, 40 divided by 5 is 8. So that means 20/40ths is equivalent to 4/8. Okay? 36 and 72. I have to think about a number that will go into both of those. I know 3 will go into 36. I believe 3 will go into 72, but I'm going to try 9 again. 9 times 4 is 36, and 9 times 8 is 72, so as long as 9 goes into both numbers, you can use it. 36 divided by 9 is 4, 72 divided by 9 is 8. So 36 over 72 is also equivalent to 4/8. If they're both even, 12 and 24 are both even numbers, so I can divide both of those by 2. 12 divided by 2 is 6, 24 divided by 2 is 12, and so 24/12 is equal to 12 24ths rather, is equal to 6/12. 24 and 48, they actually could be divided by 12. I'm going to go big. 24 divided by 12 is 2. 48 divided by 12 is 4. Now these do not have to be the same answers that I got because it depends on what you divide by. And so finding an equivalence chain or completing an equivalence chain, you have to think about what you would multiply to get from 2 to 4. And that's times 2, so you have to do the same up top. So 1 times 2 is 2. 4 times 2 makes 8, so 2 times 2 makes 4. And again, same down here. 5 doubled is 10, so if I take any number here, let's say 3, and I double it, that makes 6. 10 doubled is 20, so I double the numerator again, and so on. At the bottom, simplifying the fraction means to try to make it so you can no longer divide it to make it any smaller. So let's say, for instance, that you have 6/12. And since those are both even numbers, you can divide it by 2 halves. 6 divided by 2 is 3. 12 divided by 2 is 6. Okay? So I divided, and I ended up with 3/6. That fraction is not simplified yet, though, because both 3 and 6 can be divided again by 3. So I take 3/6, and I divide it again by 3. 3 divided by 3 is 1. 6 divided by 3 is 2, and now there's nothing else besides 1 that can be divided here. So 6/12 simplified all the way would be 1/2. 3/6 would be part of the way. So what you want to try to find is the largest number that could be divided into both parts. 8 and 10 both can be divided by 2. That makes 4/5. And 4 and 5 are not divisible by the same number, so those are simplified. 15 and 40, well, 15 is not even, so it can't be 2. 3 times 5 makes 15, and 5 will also go into 40, so I'm going to divide by 5. 15 divided by 5 is 3, 40 divided by 5 is 8. And you continue as long as what you are dividing by or multiplying by, with whatever fraction you start with, what you end up with will be an equivalent fraction.